In question 1, we have two functions f and g. F of x is 10 minus 3x, g of x is 10 upon 3 minus 2x. We have to solve the equation f of x is equals to g f of 2. So in the first step, we'll find f of x. So in the function f of x, in place of x, we'll again substitute f of x, which is 10 minus 3x. Simplifying this will become 10 minus 30 plus 9x. So this will become 9x minus 20. So f of x will be is equals to 9x minus 20. And to find g f of 2 first, in the first step, we'll find g f of x. Then the function g, which is 10 upon 3 minus 2x, in place of x, we'll substitute the function f, which is 10 minus 3x. Simplifying this, we'll get 10 upon 3 minus 20 plus 6x. Simplifying this, we'll get 10 upon 6x minus 17. Now, as the value of x is 2, we'll substitute x equals to 2 over here. So this will become 10 upon 6 times 2 is 12 minus 17. So g f of 2 will be is equals to 10 upon minus 5, which is minus 2. Now, as they both are equal, so we'll equate 9x minus 20 is equals to minus 2. So 9x will be is equals to minus 2 plus 20. So x will be is equals to 18 divided by 9. The value of x will be 18 upon 9, which is 2. In question 2, we have a curve such that dy dx is 8 upon 5 minus 2x whole squared. Given that the curve passes through 2, 7, we have to find the equation of the curve. Now, if the dy dx is given, we'll have to integrate this to bring it in the form y equals to an expression. So we can write this equation first as dy is equals to 8. We'll bring 5 minus 2x to the power 2 in the numerator, as when we are differentiating or integrating, the variable must be in the numerator, and we'll write a dx over here. Now, integrating both the sides, when we integrate dy, that will become y. Integrating 5 minus 2x, so we will increase the power minus 2 by 1. We will divide by the new power, which is minus 1, and also multiply by the derivative of 8 minus 5 minus 2x, which is minus 2. So this will be minus 2, and we'll add a plus c. So y will be is equals to minus minus will cancel. 8 divided by 2 is 4. So this will become 4 into 5 minus 2x to the power minus 1 plus c. Or we can write it as y equals to 4 upon 5 minus 2x plus c. To find the value of c, we'll substitute the points x equals to 2 and y equals to 7 as it is given. So we'll substitute y equals to 7 and x equals to 2. So this will be 5 minus 2 times 2 plus c. So c will be is equals to 7 is equals to 4 upon 1. So this will be 4 plus c, and c will be is equals to 3. So the final equation will be written as y equals to 4 upon 5 minus 2x plus 3. In question 4, we have to find the term that is independent of x in the expansion of, in the first part, we have x minus 2 upon x to the power 6. So the expansion formula for a plus b to the power n is a power n plus nc1 a power n minus 1 b power 1 plus nc2 a power n minus 2 b power 2 and so on. Now, as we need a term independent of x in the expansion, so we need to have a cube in the numerator and a cube in the denominator, as the total power is 6. So we can use nc3 a to the power n minus 3 b to the power 3. Now nc3, so this will become 6c3. A is x, so this will become x to the power 6 minus 3, and b is minus 2 upon x, so this will be to the power 3. So 6c3 is 20 into x cube multiplied by minus 8 upon x cube. X cube and x cube will cancel out, so the answer will be minus 160, which is a constant as the x terms have cancelled out. In question 4, part 2, we have to find the term independent of x in the expansion of 2 plus 3 upon x squared multiplied by x minus 2 upon x to the power 6. Now, to get a term independent of x, this 2 will multiply by a constant term over here from this expansion, and 3 upon x square will multiply by a term in x square to give us a term independent of x. Now, from the previous part, we already have a term independent of x, which is minus 160 in the expansion of x minus 2 upon x to the power 6. So we can write this as 2 plus 3 upon x squared times minus 160. Now, to get a term independent of x, a term in x squared in the expansion of x minus 2 upon x to the power 6. So as this expression is x minus 2 upon x to the power 6, to get a term in x squared, we need x power 4 in the numerator and x power 2 in the denominator. Using 6c2 a to the power n minus 2, so as a is x, this will become 6 minus 2, and this is minus 2 upon x to the power 2. 6c2 is 15, so this will become 15 times x to the power 4, and this will become 4 upon x squared. So x squared and x power 4 will cancel to give us 60x squared. So this will become minus 160 plus 60x squared. Now multiplying 2 by minus 160, we will get minus 320, which is the term independent of x, and 3 upon x squared will multiply by 60x squared. The x squared terms will cancel out, as if you multiply 3 upon x squared into 60x squared, they will cancel out and we will have plus 180. Minus 320 plus 180 will be equals to minus 140, which is the term independent of x in this expansion. In question 5, we have a diagram in which a triangle ABC is a right angle at C and M is the midpoint of BC. It is given that angle ABC is 1 upon 3 pi and angle BAM is theta. BM and MC are given by x. We have to find AM in terms of x. Now to find AM in terms of x, we'll have to first find the length of AC. So first drawing the triangle ABC. So this is A, this is C, and this is B. The total length of BC will be 2x. This angle is 1 upon 3 pi. So to find the length of AC, in the first part, we can use opposite over adjacent tan. So tan of 1 upon 3 pi will be is equals to opposite, which is AC upon 2x. So tan of 1 upon 3 pi, if we substitute this in the calculator, we'll get root 3 is equals to AC upon 2x. So AC will be is equals to 2 root 3 of x. Now to find the length of AM, we can now draw the triangle ACM. So if we draw the triangle A, C, and M, we know that the length of AC is 2 root 3 of x. And this length is x, and this is a right angle, and this is M. So now we can use Pythagoras theorem. As AM is the hypotenuse, we can write AM squared is equals to x squared plus 2 root 3x whole squared. Simplifying this, we'll get AM squared is equals to, and this was a 2x whole squared. So the length of MC is x, so this will be x squared. So this will become x squared plus 2 root 3 is 2 root 3 whole squared will become 4 times 3, which is 12. So this will be 12x squared. So AM squared will be 13x squared. Taking the square root on both the sides, we'll get AM is equals to square root of 13x squared. For the square root of x squared, the square will cancel. So we can write the length of AM as equals to square root 13 and x. In part 2, we have to show that the angle theta is 1 upon 6 pi minus tan inverse of 1 upon 2 upon 3 pi, 2 root 3 pi, 2 root 3. Now we know that ABC is a triangle. This is a right angle, which means this angle and this complete angle will be pi upon 2 or 90 degrees. As this is already 1 upon 3 pi, we can say that this total angle, so the angle BAC, so for part 2, angle BAC will be is equals to pi upon 2 minus pi upon 3. Simplifying this, we'll get 3 pi minus 2 pi, which will become pi upon 6. So the angle BAC is pi upon 6. Now, as we are trying to show that theta is equals to 1 upon 6 pi minus tan inverse of 1 upon 2 root 3, so we'll have to use a right angle triangle. So this angle will be pi upon 6 minus theta. So angle MAC will be is equals to pi upon 6 minus theta, as the total angle was pi upon 6 and this angle was theta. We already have the length of MC, which is x, and the length of AC we found in the last part, which was 2 root 3x. So now applying tan again, as this angle MAC is pi upon 6 minus theta, we can say that tan inverse of pi upon 6 minus theta will be is equals to opposite, which is MCX, and adjacent, which is the length of AC, which is 2 root 3x. X and X will cancel, and this was just tan, so this will be tan. So now taking the tan inverse, we will get pi upon 6 minus theta is equals to tan inverse of 1 upon 2 root 3. To find theta, we'll take it on the right hand side and bring tan inverse on the other side. So this will become pi upon 6 minus tan inverse of 1 upon 2 root 3, and that will be equals to theta. So we have to show that theta is 1 upon 6 pi. So we have pi upon 6 minus tan inverse of 1 upon 2 root 3. So we can see it has been proven. In question 6, we have a diagram that shows a circle with radius r and center O. The line PT is a tangent at P and angle POT is alpha. In the first part, we have to express the area of the shaded region in terms of r and theta. Now, first of all, as PT is a tangent, it means this will be a right angle. Now, the shaded region will consist of, the shaded region will consist of the arc length PQ. So this will be arc PQ plus PT plus the length QT. Now to find the arc length PQ, we'll use the arc length formula, which is S is equals to R theta. So this will be R times alpha. To find the length of PT, we can use opposite over adjacent tan. So this will become tan alpha will be is equals to PT upon R. So PT will be is equals to R tan alpha. And to find the length of QT, first we'll find the length of OT and then subtract OQ, which is R. So the length of OT we can use adjacent to our hypotenuse cos theta. So we can write cos alpha is equals to the length adjacent, which is R, upon hypotenuse, which is OT. So OT will be is equals to R upon cos alpha. Now, so we can write QT will be is equals to the total length R upon cos alpha minus R. So the perimeter, we can finally write it as the perimeter will be is equals to R alpha plus R tan alpha plus R upon cos alpha minus R. In part 2, in the case with alpha is 1 upon 3 pi and R is equals to 10, we have to find the area of the shaded region. Now to find the area of the shaded region, first we find the area of the triangle OPT and subtract the area of the sector. So for the shaded region, in the first part, we'll find the area of triangle. So that will be half into base. So the base is PT multiplied by the height, which is OP. Now we know that the length PT was R tan alpha. So in place of PT, we can write 1 upon 2 into R. So R is 10 into tan of alpha, which is 1 upon 3 pi, multiplied by the length of OP, which is R. So R is equals to 10. Substituting this value in the calculator, we will get tan multiplied by tan of 1 upon 3 pi divided by 2. So tan of 1 upon 3 pi is root 3. So this will become 10 times 10 100 root 3 upon 2. Now to find the area of the sector, which we'll use the formula half R squared theta. So the area of sector will be half R squared theta. So R is 10 and alpha was 1 upon 3 pi. So we can write this answer as 100 pi divided by 6. Now to find the area of the shaded region, we'll subtract the two areas. So the area of shaded region will be is equals to 100 root 3 upon 2 minus 100 pi upon 6. Substituting this value in the calculator, we'll get 100 root 3 divided by 2 as 86.6, and 100 into pi divided by 6 is 52.35. So minus 52.35. So 86.6 minus 52.35 will be equal to 34.25. 34.25 unit square. Now, as we had to give our answer correct to two significant figures, so we will make 34.25 and write the final answer as 34. In question 7, part 1, we have to prove the identity 1 plus cos upon 1 minus cos minus 1 minus cos upon 1 plus cos as 4 upon sin tan. Now, to prove any identity, it is easy if we start applying basic algebraic operations, and instead of writing cos theta, I'll just be using the letter C. So taking the LCM in part 1, from the left hand side, the LCM will be 1 minus cos and 1 plus cos. So this, when we take the LCM, 1 plus cos will multiply by, so this will multiply by 1 plus cos. So this will become 1 plus cos whole squared, minus 1 minus cos will multiply by 1 minus cos. So this will become 1 minus cos whole squared. Expanding 1 plus cos whole squared, we'll get 1 plus 2 cos plus cos squared minus. Now it is important to keep the brackets as the signs will change, as this negative sign is with the complete bracket. So this will become 1 minus 2 cos plus cos squared, and the denominator will remain 1 minus cos and 1 plus cos. Simplifying the numerator, we'll get 1 plus 2 cos plus cos squared minus 1 plus 2 cos minus cos squared. So the cos squared term will cancel, 1 minus 1 will cancel, and we'll get 4 cos upon 1 minus cos, 1 plus cos. Now we can write 1 minus cos, 1 plus cos as 1 minus cos squared. We will be using the identity x minus y and x plus y is equals to x squared minus y squared. Now we know that 1 minus cos squared is sine squared, so this can be written as 4 cos upon sine squared. Now to convert it to 4 upon sine tan, I can write sine squared as sine multiplied by sine. Now as sine upon cos is tan, so for cos upon sine, we will write tan in the denominator, and we already have sine, so this will be 4 tan theta sine theta. In part 2, we have to solve the equation sine multiplied by the term that we had to prove the identity, and this is equals to 3. So in part 2, it is sine multiplied by, now we had proved that this whole bracket is equals to 4 upon sine tan. So in place of this, we will replace it with 4 upon sine tan, and this is equals to 3. Sine and sine will cancel. So tan theta will be is equals to 4 upon 3. Now to find the value of theta, we will first find the basic angle, taking tan inverse of 4 upon 3. So tan inverse of 4 upon 3, if we substitute this in the calculator, we'll get 53.13. Now, as a basic angle is 53.13, we'll make this in the positive quadrants as tan is positive. So this will be A, C, T, and S. The basic angle will be made in the first quadrant. And so this is 53.13 and this is 53.1 in the third quadrant. Now to find the value of theta, the first angle will be anti-clockwise from the x-axis. So theta will be 53.1, as we have to give our answer to one decimal place for angles. And the second angle will be 180 plus 53.1, which is 233.1 degrees. In question 7, we have 3 points that have coordinates a 0, 7, b 8, 3, and c 3, k, k. We have to find the value of k for which c lies on the line that passes through a and b. Now, as c lies on the line that passes through a and b, we can attempt this question in two different ways. We can use a gradient formula as if points are on the same line, the gradients are equal. So we can equate the gradient of AC and the gradient of CB. As the C coordinates have the same variables, we'll be able to find the value of K. or we can find the equation for AB and substitute the values for C, which are 3k and k. So if we find the gradient for AB, we'll get y2 minus y1, which is 3 minus 7 divided by 8 minus 0. So the gradient will be minus 4 upon 8, which is equals to negative 1 upon 2. So the equation for AB will be, we can use the point A for the equation. So the equation will be y minus y1, which is 7, is equals to negative 1 upon 2 into x minus 0. Simplifying this, we'll get 2y minus 14 is equals to negative x, or we can write it as 2y is equals to negative x plus 14. Now to find the value of k, we can substitute 3k in place of x and k in place of y. So we'll get 2 into k is equals to minus 3k plus 14. Simplifying this, we'll get 5k. So this will become 2k plus 3k, which is 5k equals to 14. And k will be is equals to 14 upon 5. Or we can write it in decimal as 2.8. In part 2, it says that find the value of k if C lies on the perpendicular bisector of AB. Now, if C lies on the perpendicular bisector of AB, it means that the perpendicular bisector, which is a right angle. So first we'll find the equation for the perpendicular bisector and substitute the values of C, 3k, k into that equation. Now to find the equation of the perpendicular bisector, first we'll find the gradient of AB, which we already have as negative 1 upon 2, which means that the perpendicular bisector will have a gradient of positive 2. Now to form the equation, we need the midpoint as the perpendicular bisector passes through the midpoint. So the midpoint of AB will you find using the formula x1 plus x2 upon 2. So that will become 0 plus 8 upon 2, comma 7 plus 3 upon 2. So 8 upon 2 will be 4 and 10 upon 2 will become 5. So this is a point on the perpendicular bisector. To form the equation, we'll again use the formula y minus y1. So y minus y1 we can take as 5 is equals to 2 into x minus x1, which is 4. Simplifying this, we'll get y minus 5 equals to 2x minus 8, or y is equals to 2x minus 8 plus 5, which is equals to 2x minus 3. Now substituting the values of C, 3k, k into this equation. So in place of y, we'll put k, and in place of x, we'll put 3k minus 3. So this will become k is equals to 6k minus 3. Simplifying this, we'll get k minus 6k is equals to negative 3. Minus 5k is equals to minus 3. The negatives will cancel out. So k will be 3 upon 5, or we can give it in decimal as 0.6. In question 9, it says that a water tank holds 2000 liters when full. A small hole in the base is gradually getting bigger so that each day a greater amount of water is lost. On the first day after filling, 10 liters of water are lost, and this increases by 2 liters each day. In part A, we have to find how many liters will be lost on the 30th day after filling. Now, in part 1, as the increase is a constant by 2 liters each day, we can say that as the initial value was 10, and it is increasing by 2 liters each day, which means that their common difference will be 2. So we also know that as there's a common difference, we are dealing with an arithmetic progression. So if you want to find out how many liters will be lost on the 30th day after filling, we know that the nth term formula for arithmetic progression is a plus n minus 1 times d. As we are looking for the value on the 30th day, we'll just use the formula where a is 10 plus this will become 29 and the common difference is 2. So 58 plus 10 will become 68. So on the 30th day, 68 liters will be lost. In one part B, it is asking us the tank becomes empty during the nth day after filling. We have to find the value of n. Now, as the total was 2000, so we want to find out at which value of n will the total sum be equals to 2000. Now we know that the sum of n terms for NAP is given by n upon 2 into 2a plus n minus 1 into d. We know that the total sum will be 2000 as it held 2000 liters when full, so this will be 2000. We do not know the value of n, so this will remain unknown. We know that a is 10, so this will become 2 into 10 plus n minus 1 into 2, as the common difference was 2. Cross multiplying, we'll get 4000 is equals to n into 20 plus 2n minus 2. So 20 minus 2 will become 18. So this will be n into 18 plus 2n, which is equals to 4000. Opening the bracket, we'll get 18n plus 2n square is equals to 4000. Forming a quadratic equation, we'll get 2n square plus 18n minus 4000 equals to 0. Substituting this in our calculators, we'll get one of the values of n as 40.44, and the other value of n will be equals to minus 49.44. Now, as n cannot be negative, we'll ignore this value. And as we have to give n in an integer form, so either we can take the answer as 40 or 41. Now we need to, as at 40.44, the total sum was 40,000 for 2000. So we'll be taking n as 41, as on the 41st day it will become completely empty. So we won't be able to take 40 as our answer, as if we take n is equals to 40, we will see that the sum will be less than 2000. In part 2, it says that assume instead that 10 liters of water lost on the first day, and the amount of water lost increases by 10% on each succeeding day. So now whenever we have a percentage involved, it means that we are dealing with a GP now. So in part 2, as the amount of water loss is increasing by 10% each day, we can form an equation for a GP by first assuming that, let's say, the original value was 100%, the original loss of water. So on each succeeding day, it will increase by 10%. So to find the common ratio, we'll divide 110 by 100, which will be is equals to 1.1. Now the question is asking what percentage of the original 2000 liters is left in the tank at the end of the 30th day. Now, first of all, we need to find out how many liters of water are lost after 30 days. So we'll apply the sum formula. Now the sum formula for n terms of a GP is given by a into r to the power n minus 1 upon r minus 1. A was 10, because the common ratio was 1.1. N will be taken as 30 minus 1 upon, so common ratio was 1.1 minus 1. Substituting this value in the calculator, we'll get 1.1 to the power 30. So 1.1 to the power 30 minus 1 is 16.44 times 10, and then dividing by 0.1, the answer will be 1644.9. We round it off to 1645. So we know that after 30 days, 1645 liters of water were lost. And now we have to find the percentage of the original 2000 liters that is left in the tank. So the amount of water left will be 2000 minus 1645, which is equals to, so 2000 minus 1645 is equals to 355. Finding the percentage, we will write it as 355 divided by 2000 times 100. So 355 divided by 2000 times 100. The final answer will be 17.75%. In question 10, it says that a diagram shows part of the curve y equals to 8 upon x plus 2x and a minimum point m. In the first part, we have to find expressions for dy dx, d square y dx square, and integrate integral of y whole squared. So as we know that y equals to 8 upon x, we'll write it as 8x to the power minus 1 plus 2x. Now finding the dy dx, in the first step, we'll multiply minus 1 by 8, so that will become a minus 8x to the power minus 2, as we decrease the power by 1 when differentiating, plus, so the x power is 1 over here, 1 times 2 will become 2, x to the power 0. So we can write dy dx is minus 8 upon x squared plus 2. Now in the next step, we have to find d square y upon dx square, which means we differentiate dy dx again. So we'll multiply minus 2 by minus 8, that will become a plus 16. We'll decrease the power of it by 1, which will become a minus 3. And differentiating 2, it will become a 0 as it is a constant. So we can write it as 16 upon x cubed. And in the third part, we have to integrate y whole squared. So integrating y squared, first of all, we'll write it as 8 upon x plus 2x whole squared and integral sign. So before integrating, we'll expand this expression. So this will become 64 upon x squared, a square plus 2 times ab. So that will be 8 upon x into 2x and then plus b squared. So that will be 2x whole squared. Simplifying this before integrating, we'll write it as 64 x to the power minus 2. This will cancel out. So this will become a to the 16 times 2, 32 plus 4x squared. Now applying the integration sign all these three terms. So integrating 64x to the power minus 2, we'll increase the power by 1. So this will become minus 2 plus 1. So 64x to the power minus 1. And we divide it by the new power. Plus integrating 32 will make it 32x. And we increase the power by 1 over here. So this will become 4x cubed divided by the new power, which is 4x cubed upon 3. So we can write this as minus 64 upon x plus 32x plus 4x cubed upon 3. So this was the first part. Now in the second part, it is asking us to find the coordinates of M and determine the nature of the stationary points. Now, as M is a minimum point, it means that dy dx will be equals to 0. So in part 2, we'll put the dy dx that we had in our first part. So dy dx was minus 8 upon x squared plus 2 equals to 0. Taking the LCM, we'll get minus 8 plus 2x squared equals to 0. We'll write it as 2x squared is equals to 8 or x squared is equals to 4. Taking the square root, we'll get the values of x as plus minus 2. Now to find the nature of the stationary points on the part of the curve, so as M is on the positive side, so we'll be taking the value of x as 2. Now to find the nature, we'll substitute this value of x into the double derivative that we found, which was 16 upon x cubed. So as we had d square y upon dx squared. So in this part, it is asking us to find the stationary point on the part of the curve for which x is less than 0. So we'll be taking x equals to minus 2. So now using 16 upon x cubed, so substituting minus 2 over here, we'll get 16 upon minus 8. As it is a negative, it means that the nature will be a maximum point. In part 3, we have to find the volume obtained when the region bounded by the curve, the x-axis, and the line x equals to 1 and x equals to 2 is rotated through 360 degrees about the x-axis. So to find the volume, the formula is volume is equals to pi times the integral of square of the function y. Now, we had already found that y squared integral was minus 64 upon x plus 32x plus 4x cubed upon 3. We just have to apply the limits 2 and 1. So applying the limits 2 and 1 to minus 64 upon x. So in place of x, first we'll put the upper limit, which is 2 plus 32 times 2 plus 4 into 2 cube upon 3. And subtracting the lower limit, we'll get minus 64 upon 1 plus 32 times 1 plus 4 into 1 cube upon 3. Substituting this value in our calculators, it will simplify down to 220 upon 3, and we will add pi to the final answer. So the final volume will be 220 pi upon 3. In question 11, we have a function f of x, which is defined by 6x minus x squared minus 5 for x is an element of real number. It means x is taking up all the values negative and positive. In the first part, we have to find the set of values of x for which f of x is less than or equals to 3. So f of x is 6x minus x squared minus 5, and we'll write it as less than or equals to 3. So simplifying this, to make the x squared positive, we can write it as x squared minus 6x plus 5 plus 3, and that will be greater than or equals to 0. So we have taken the term on the left hand side to the right hand side. So we can now write it as x squared minus 6x plus 8 greater than or equals to 0. Factorizing this, we will get x minus 4 and x plus 2 greater than 0. Now, to give the correct inequality sign, to understand this, it is better to sketch a rough graph. So we know that this is the upper limit 4, and this is the lower limit, which is minus 2. So this will be a minus 2 as well. So this will be x plus 4 and x minus 2. And this is a plus 2 and a plus 4. Now, as x minus 4 and x minus 2 is greater than 0, we are looking for values of x that will give us the function greater than 0. Now we know that the function is greater than 0. It is positive above the x-axis and negative below the x-axis. So we'll be taking values of x which are greater than 4 and values which are lesser than positive 2. So we'll give our answer as x is greater than or equals to 4 and x is less than or equals to 2. In part 2, it says that given that the line y equals to mx plus c is a tangent to the curve y equals to f of x, so that 4c is equals to m square minus 12m plus 16. So we'll just equate the two equations. So in part 2, as it is a tangent, we'll equate the equation of the line which is mx plus c. So this will become mx plus c is equals to 6x minus x squared minus 5. Now, bringing the term on the right hand side to the left hand side, we'll write the equation as x squared minus 6x plus mx plus c plus 5 equals to 0. Now, as we know it is a tangent, it means that the discriminant b squared minus 4ac will be equals to 0, as there is only one point of intersection. From the equation, we can say that the value of a is 1. B will be, so taking x common over here, we'll get minus 6 plus m. So we can write b is equals to minus 6 plus m. And c will be is equals to c plus 5. Applying b squared minus 4ac, we'll get, so b squared will be minus 6 plus m whole squared minus 4 into 1 into c plus 5 equals to 0. Expanding this, we'll get 36 plus, so this is m, so this will be 2 into minus 6 into m plus m squared minus 4c minus 20 equals to 0. So this will become 36 minus 12m plus m squared minus 4c minus 20 equals to 0. We have to bring our equation in the form 4c is equals to, so let's take the 4c on the other side. So this will be 36 minus 20, which is 16, minus 12m plus m squared is equals to 4c. So we have it in the form as it was given. 4c will be is equals to, we can rearrange it to write it as 4c is equals to m squared minus 12m plus 16. In part 3 says that the function g is defined by g of x 6x minus x squared minus 5 for x greater than or equals to k. We have to express x 6x minus x squared minus 5 in the form a minus x minus b whole squared. Now to convert this into the form, we can use completing the square method or the comparison method. So the original expression is 6x minus x squared minus 5, and we have to convert it to the form a minus x minus b whole squared. So if I use the comparison method, I will simply expand the expression. So this will become x squared minus 2bx plus b squared. And this will become a minus x squared plus 2bx minus b squared. So we can write it as minus x squared plus 2bx minus b squared plus a. Now comparing it with the original expression, the term with x is 6 and over here the term with x is 2b. So we can say that 2b will be is equals to 6, which means b is equals to positive 3, and minus b squared plus a is a constant over here, and on this side we have negative 5, so we will equate it to negative 5. As the value of b was 3, so we'll write 3 whole squared plus a is equals to minus 5. So a will be is equals to minus 5, and this will come over here and become a plus 3 squared, which is 9. So a will be equals to 4. So we can write a final expression as 4 minus x minus b. So the value of b is 3. So this will become 4 minus x minus 3 whole squared. In part 4, we have to state the smallest value of k for which g has an inverse. So now as x is greater than equals to k and it has a max turning point at 3, 4. So to find the smallest value of k, which is a value of x, now we know from the expression that the turning point is 3, 4. So as this is a turning point and it is moving forward from over here, for it to be a for it to have an inverse, it must be a one-to-one function. So the smallest value of k it can have is 3. So in this part, the value of k will be equals to 3. In part 5, we have to find, for this value of k, we have to find an expression for g inverse. Now to find the inverse of a quadratic function, it is important that we convert it to the complete square form. Now, as you already have the expression 4 minus x minus 3 whole squared, so we know that g of x is equals to 4 minus x minus 3 whole squared. So we'll write y over here is equals to 4 minus x minus 3 whole squared. To find the inverse, we'll first exchange the values of x and y. So this will become x equals to 4 minus y minus 3 whole squared. Bring the y minus 3 on the left hand side to make it positive, and we'll bring the 4x on the other side, so this will become 4 minus x. Taking the square root on both the sides, we'll get y minus 3 is equals to 4 minus x square root, and finally making y our subject, this will be y equals to square root of f minus 4 minus x plus 3. So finally we can write our expression for g inverse of x as square root of 4 minus x plus 3.